Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is cities' colors. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. We once again find ourselves exploring the beautiful regions of Chefland. Now, there are n cities in a row and each city has a color preference of CI and has a wealth of WI. Initially we are at city 1 and we are at color 0 and we have 0 coins. For simplicity's sake, it is guaranteed that C1 and W1 are equal to 0 and we can perform the following operations any number of times. We can set our color to any integer that we wish. This will reduce the amount of coins that we have by k. Then we'll move from cti to cti plus 1. If our current color is same as the color that we're moving, that is I plus 1, we will gain wi plus 1 coins. And if that is not the case, we'll lose the same amount of coin. And at the end, we have to reach till city n. With this, our travels will end. Note that we can have a negative amount of coins at any point of time. We need to find the maximum number of coins that we can end up after this trip. So we have these different cities, right? This is city I and this is city I plus 1. We are given this k integer as well. At the end, we are trying to reach till this nth city. So for each of the city, we have a color given and the wealth of the city. When we switch to I plus 1, if our color is same, we will gain W plus WI coins. And if, sorry, we will gain WI plus 1 coins. And if the color is not same, we will lose the same amount. If we want to change our color to anything else, this will cost us K coins. So for the input format, we have t test cases. And for each test case, we will have two lines. The first line will contain the integers n and k. The second line will contain n-spaced integers, that is the our array w, and the third line will contain again n integers, that is our array c, so having elements c1, c2 till cn. As for the output, we have to output a single integer, that is the maximum number of coins we can get after our travel ends. For the constraints, number of test cases will go from 1 to 10 raised to 5. Value of n will go from 2 to 2 into 10 raised to 5. Value of k and w will go from 0 to 10 raised to 9. And the value of coins will go from 0 to n. And as we have seen initially, the city 1, its color and the wealth there will be 0. Rather than seeing the sample inputs, let's see how we can approach the solution. Once we build the intuition, we can solve it. So we have these different cities, right? We are traveling from one city to another, and then finally we are trying to reach the nth city. Now in this case, whenever we are going from a city J to a city I, what are the things that can happen? Now, if both of the colors are same between the city J and city I, we will gain WI coins. If the color is not same, we will lose WI coins, right? And in case that we try to switch our color, the color that we have at J to the color at I, we will have to give up K coins. So in a way, this is a dynamic problem, right? We are trying to go from city J to city I, and we are trying to find out what is the maximum coins that we can collect here. So what we can do is for each city I, we can check the previous city and see what is the best way to reach the current I and have the maximum number of coins. So let's take this example. We are going over all the values of I cities, right? And then between, let's say, 0 to I, we'll travel over all the previous cities and check what is the best way that we can reach from J to I. Now, in between this, we are assuming that the colors are not going to be same and we are going to lose them. So it would mean that in between J and I, whatever cities are there, we are going to lose those wealth. So it will be J plus 1, W of J plus 2 till we reach W of I minus 1. These are all the coins that we are going to lose. Why? Because we are only focusing over the city I and J. Now if the color is same, right, we are going to gain WI coins. If the color is different, then we will need to change the color that will give us a penalty of k. So to find this sum of wealth, what we can do is we can simply have a prefix array, right? So at any point of p, we'll initialize our dp of I that will give us the maximum coin at that index. Since we are coming from j, we will take what is the maximum coins we can get at ctj with dp of j. Then, since we are reaching I, we know that if the color is same anyway, then we will gain wi coins. If the color is not same, then what we are going to do is we are going to change the color when we are at city j, and in that manner we will incur a penalty of k. But between these, whatever cities that we have, that is nothing but our prefix sum with I minus 1, and we'll subtract the prefix from j. And in case the color is same, that is if Cj is equal to C of I, we will be 0, otherwise we'll give a penalty of k. So with this, we can go over all the cities, and finally what we'll have is, we'll get the dp for each index, what is the maximum coin that we can get, and finally we'll check what is the maximum coin that we can get when we want to reach the nth city. But this solution has a time complexity of n square. As we can see, for each value of I, we are traversing over all the previous cities that we call our j, going from 0 to I. And as we have seen, the constraints are not lenient enough that we can do a O of n square solution. So let's try to make it more efficient. Let's try to break this down. So what we have here is, for each dp, we have dp of j. With this, we add up the weight or the coins that we are going to gain once we reach I. Then we have a subtraction of the coins that are in between. Let's call them p of I minus 1 minus the p of j that we have. And finally, we decide whether we are going to get a penalty or not based on the color of I and j. Now, if we rearrange this, we have dp of j minus this p of j that we have here, and another component that we have is w of I and p of I minus 1. So with this, what we have is, we have two components, one dependent on I and one dependent on j. K is a constant that we are going to choose when we have c of j not equal to c of I. So in case c of I is equal to c of j, it means that we are just trying to find what is the maximum sum that we can get for our index, right? If we check in the value of j, what is the maximum of our index for the color that is same. So when we have the same color, we are trying to find out what is the maximum coin that we can get. So we can store that in a, let's say, a array called best. In this, we'll have each color, and for each color we'll have what is the max coins that we can get. That will be dp of I and the other term. This is when we have our colors are same. But what happens if colors are different? If colors are different, it means that we are trying to find what is the global best. Irrespective of each color, we're simply trying to find what is the global best that we have across all of this. So with these, we eliminate the term of j and we only have one term. So with this, whenever we are moving a city, we have two options. We can choose the global best and then check what is the cost of moving next and what are the number of points that we will gain. And this is the first option. And the second option we'll have is choosing the same color max. So in global best, we take a penalty of k because we need to change the color. In local best, since we know that the colors are same, we don't take the k penalty and we simply check what is the max value. Then at the end, since we are trying to reach n, we'll simply check what is the coins that will be lost going from p of n from p of I, and with this we'll simply add up whatever dp of I that we got. We'll take the max value of these, and at the end we'll have our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve and take the input of n and k. Then we have to take the input of color and weight of each city. Once we're done with that, we also need to construct a prefix array for the weights. Once we are done with that, we initialize our best array for all the n colors and we initialize it with the negative value of int max. Then once we are going over all the cities, we have to update our global best and our local best. So what is the option? The option is that first we'll take the global best. In this case, we'll gain the wi, that is, since we are reaching I, we'll have to subtract the value of coins that we are going to be losing here. And since this is the global best, we also gain a penalty of k for changing colors. Now if that is not the case and you're trying to move with the when the color is same, we choose the local best that we store in our array best. Then we again add up the gain and subtract the coins that are going to be lost there. Then we update our global and local best. So with this, we have all the DPs for all the I states. Then at the end, since we're trying to move to the n city from I, we calculate again what will be the cost here and what are the number of coins that we gain max. So we initialize our result as the negative value of all the sums that we have in our weight. This is the minimum that we can get, that is, by losing all the coins along the way. After this, we simply have to find out what is the maximum to reach the n-1 city, sorry, the nth city. For that, we have the prefix n-1 minus prefix of I. So these are the coins that we are going to be losing, because along this path, our color is not going to be same. So we lose this and we have dp of I. We take whatever is the maximum and at the end, we print this result. And this result will be the maximum number of coins that we can gain. And as you can see, I've got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and k, then we have our array w and c. We construct our prefix array on w, then we initialize our global best and our best array. Then for each city, we traverse it and we have two options. We can go for the global best that we have, or if the color are same, then we can go with the best that we can get within that color. Once we have this, we update the global and the local best. Then at the end, we check what is the maximum coin that we can get while we reach the nth city going from I. We take whatever is the maximum and at the end we print. This result is the maximum coin that we can gain after our travels end. And as you can see, I've got an AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day and I'll see you in the next video.